In this problem, we're given the Antoine equation for benzene, where it's a log of the saturation pressure as a function of temperature, where temperature is in degrees Celsius and pressure is in torr. And we want to estimate then from this information what is the heat of vaporization of benzene at 60 degrees C. So what we're going to do is take advantage of the Clausius-Clapeyron equation, and we want to note a couple things. This is the natural log, whereas the equation for the Antoine equation is log base 10. This is absolute temperature, and we'll use Kelvin, and this is a constant. But what we want is essentially the slope of the natural log of the saturation pressure versus the inverse of the absolute temperature, because that plot should be a straight line if delta H is not a function of temperature. So what we're going to do is assume over a narrow range that delta H is not a function of temperature. So if we assume this, what we're going to do is use the Antoine equation to calculate values of the saturation pressure. So what we're going to do is calculate the saturation pressure at 55 centigrade and 65 centigrade, and assume over that narrow temperature range we're going to get a pretty good estimate if we just take the slope to fit the Clausius-Clapeyron equation. So we'll calculate these values. So we've substituted in 55 centigrade and 65 centigrade into the Antoine's equation here, and we're going to calculate first the log to base 10 and then calculate the actual saturation pressure. That's these values. So these are from the Antoine equation. We then take the log of these values to get this, and we calculate also the temperature. So we take 273.2, add it to 55, take the inverse, that's where we get this number. Same thing for 65. So now the heat of vaporization divided by R, the negative of that, should be the slope of this line for these data points. So minus the heat of vaporization divided by natural gas constant. That's going to be the slope. And delta log of P sat, delta 1 over absolute temperature. We're just going to take the values from the table and substitute in here. So I've substituted in the values here using a gas constant value of 8.314. So we're going to have with heat of vaporization in joules per mole, the Kelvin cancel. And we've calculated the heat of vaporization for benzene at 60 degrees, 32.3 kilojoules per mole. This is at 60 degrees C for the heat of vaporization of benzene.